All right, you've had a couple problems on that last lesson where you had some parallel lines. You remember that overlapping triangle stuff? We separated the triangles. Do you remember doing that yesterday? Yes? Yeah. What we're going to do is we're going to talk about a triangle that has some parallel sides again. But we're going to get a little bit more specific about this. So here's let's make this a little thicker. There we go. Let's do this. Let's put a parallel side right here. This side right here that I'm drawing is parallel to that side on the left. All right, so there we go. There's our situation. You got two overlapping triangles, don't you? But we're not necessarily talking about the angles inside of there. We're going to talk about the segments that they cut off, and I'll show you what I'm talking about. Let's use the letters they use in the book. A, B, C, D, E. D, E. All right. Now this is a theorem, I believe. Yep, it's theorem 7.5. I don't care that you know the numbers, but it is a theorem. And here's basically what it says. We know that we do have two similar triangles here. Let me just show you this. We can say that if I compare, here's a couple more comparisons. So write this down. It's very important you write this down because you're not going to remember this. There's no way you're going to remember this just by sitting there doing another class assignment and looking up at me every once in a while just to pretend that you're paying attention, right? Because I know that happens, all right? Just so that you know, I do know that that happens. All right, so let's do this. If I wanted to compare AB, now look at AB though, but AB is not an entire side of a triangle, is it? Before, we compared entire sides of a triangle. This is just a part of a triangle. Everybody see that? So we didn't really compare just parts of a triangle before. But we're going to do that now, though. So if these two lines are parallel right here, see how it cuts off this segment AB and it cuts off this segment BC? Well, watch what we can do. If I take AB and compare it to BC, what do you think you can compare down here on this side? So if I take this one right here and compare it to this one right here, what do you think I could set that equal to down here? Just take a wild guess. Yeah, DE over EC, exactly right. So if I compare this short one to this longer side of the triangle, it's going to be the same thing over here. Compare this short side to this longer side of the triangle. And so I could go DE and then compare that to EC. All right? So that's very general. We'll put some numbers here in a second. All right? Sometimes I do this. Instead of using all these letters right here, sometimes that gets a little confusing. What if I made this W, so that segment is W, and this is X, and that little one's Y, and that one's Z? Sometimes that might be a little easier to see. So what can I compare? I can compare W to what? To X, and that would equal what to what over here? Y to Z. Does that make any sense? That's a relationship that I can have. That's a theorem. Now remember, this is a little different than what we've done before because this is not an entire side of a triangle, so it's a little bit different. But as long as these two segments right here are parallel, this side of the triangle is parallel to this side of the little triangle, if that's true, then it cuts this side into proportional parts with this side. All right? That was a little bit wordy right there, but you understand what I'm saying? We now have a proportion because the ratio of this to this is equal to the ratio of this one to this one. Does that mean W and Y are both the same exact length? No. Doesn't mean that X and Z are both the same length. But if I compare this one to this one, it's going to be the exact same thing as this to this. For instance, if this was like 1 and this was 2, if this was double this, what if this was 3? What would this one be? It'd be 6. Does that make sense? All right, because this one is double this one. Now, it's not always going to be double, but that was just a quick little example. Let's actually do an example. Let me grab this triangle again. And let's do this. Let's grab this little thingy right there. I think I grabbed it all. Yep. All right, we'll make it look the same just to make it easy. And let's put some stuff in here. This is an example straight from the book. This is P. Well, I'm sorry. Don't write that. Let me try to draw it the way the book does. I'll make it look a little bit more like theirs. So theirs looks like this. like that, and like that. And then you got a parallel line coming through like this. Now remember, for this thing to be true, these two lines have to be parallel to each other. If they don't tell you they're parallel to each other, you can't say anything that we've been doing here. So let's put some letters in here. This is P, S, R, and this is T and Q. All right, here's what the problem says. This is an example. It's on page 484 if you want to look at it. It tells you that they're parallel, and it says that PT, let's just write this stuff down so you see it the way it looks in the book. PT is 7.5. It tells you TQ, which is 3. And it also tells you SR, which is 2.5. And the question says find PS. All right? So that's pretty much exactly the way it looks straight from the book. So here's our picture. We're going to plug stuff in. So we put in PT, 7.5. So I put a 7.5 right here. They tell you TQ, which is 3. Put that right there. They tell you SR, which is this little one right here, and that's 2.5. And they ask to find PS. We'll just call that X. Is that right? Just to make it one letter. So what do you think? This is really straightforward from what we just taught, right? I mean, it's hardly any different. So what can you do here? What do you think? You got to set up a ratio. Let's start over here with the X. What are we going to compare X to? To the 2.5, right. So take this side to the other, or this segment to the other segment on that side of the triangle. Okay, so compare X to 2.5. Now that's going to equal, what are we going to compare over here? 7.5 to what? 3. To 3. Good. So we put 7.5 to 3. Does that make sense what we're doing? All right. It goes exactly from what our theorem said we could do, doesn't it? So I'm comparing this one to this one, and I compared this one to this one. Now you could do it another way. If you wanted to, you could, I'll do this in a different color. You could, if you wanted to, let's see if this also works. What if I compare X to 7.5? What do you think I'm going to do over here? 2.5 to what? To 3. Let's see if that works. So X to what? 7.5. And then what? 2.5 to 3. Let's see if that works. Now what are we going to do here to solve for X? We're going to cross multiply, aren't we? Okay, so let's do that. Cross multiply like this. What's this? It's 3x. What's this? I don't know. It's 2.5 times 7.5. Everybody see that? Now what are we going to do here? When we're going to get x by itself, how do we get rid of the 3? Divide both sides by 3. Good. All right, that cancels out. And now it's just a matter of just chucking all that into a calculator. So let's do that. So 2.5 times 7.5, that's 18.75. Take that, divided by 3, 6.25. Good. 6.25. And so that is what this is right here. Does it make sense that it's 6.25? Yeah, because look, 3 is just a little bit bigger, and look what side it has, 7.5. This is just a little bit smaller, so x is going to be a little bit smaller than this, isn't it? 6.25 is just a little bit smaller than that. Yep, works perfect. Makes sense. What if I got some crazy number like 328? Would that make sense? No, there's no way. So try it again, right? If you get some real whacked out crazy number, try something else. So, if you can, try to make sure it makes sense. Look at this one right here. Remember I said, let's see if we could compare this way, like across from each other. Let's see if it works. Does it work? Yeah, because the cross multiplication is exactly the same, isn't it? This was 3x. That's 3x. This is 2.5 times 7.5. Same thing right here, isn't it? So would you agree that you can compare two different ways? Yep, you can go from this one to this one, and this one to this one, right? So top left to bottom left. Top right to bottom right. Or you could do what? Top left to what? Top right. Or you can go bottom left to bottom right. You can't do it this way. You can't go top left to bottom right. Do they have anything in common? Does top left have anything in common with bottom right? No. So you cannot compare them that way. Everybody hear that? Okay, you can only compare them if they have something in common, right? These are both on the left side, so you can compare the two left sides and the two right sides. Or you can compare the two that are on the top and the two that are on the bottom. But you can't compare the top left to the bottom right because they got nothing in common. We good with that? All right. That's not so bad, is it? No, it's pretty easy, I think. All right, good enough for that one. Let's do another one. Did we do? Oh, yeah. Remember we did mid-segment? Remember that word? Yes. But what did we do the mid-segment of? Not a triangle. A trapezoid. Very good. We did it of a trapezoid. But this time, we're going to do a mid-segment of a triangle. So let's put a triangle right here. And let's talk about the mid-segment. So any idea what the mid-segment is? It was only last chapter, wasn't it? That we did this stuff? The mid-segment, what did it do? It connected the... What word is in there? Mid what? Midpoint. Midpoint, right. So there's the midpoint of this side. Let's connect the midpoint of this side, too. About right there. Okay. And let's connect them. I'm going to do this connection in a different color. So, boom, right there. All right, so I connected the midpoints, didn't I? So that and that are equal, and this one are equal. So that red line right there is called the mid-segment. Now, this is not of a trapezoid. Spell it right? Yep. This is the mid-segment of a triangle. Triangle. All right? But a lot of stuff kind of holds true. This mid-segment, I connected the midpoints. What does it look like this red line and this bottom line are? Looks like they're parallel, doesn't it? Do you remember at all what that mid-segment was? Man, they're dropping like flies. Look, 1, 2, 3, 4. Bang, bang, bang. Is it that bad? Am I really that boring? I mean, I know I'm not the most exciting person in the world, but do I really put that many people to sleep? I don't know. I guess I do. People always have a reason. Yeah, then on Mondays, because it's Monday, it's the beginning of the week. So, you know. And if it's Friday, well, it's the last day of the week. And then it's Wednesday or Thursday, it's in the middle of the week. So, I don't know. There's too many excuses. Anyway, let's take a look. This mid-segment right here is parallel to this side. And so, look, if it's parallel to this, then that whole thing goes true. I can compare this to this, right? And I can compare this to this. Would you agree? All right. Just knowing that that's the mid-segment, I could do that. You could also talk about the length of this. Do you remember on the trapezoid, the mid-segment was the average of the top and the bottom? Remember that? It was the average of the bases. We added up the bases and we divided by 2. But this time I don't have 2 bases. I only have 1 base. So take a wild guess. If this was 10 right here, what do you think this mid-segment length is going to be? It's going to be 5, exactly. It's just half of the base. That's pretty easy, isn't it? That's easier than the trapezoid thing, right? The trapezoid thing wasn't that hard. You just added 2 together and you divided by 2. But on this one, it's even easier. This is 10, this is half of it. Or, of course, if you knew the mid-segment, what would this base be right here? That would be 10. It's just double it. All right, so there's new stuff. Wow, that kind of snuck up on me. Yeah, it is. I'll give you a little worksheet, okay? We're almost finished, so you can do the stuff that we talked about today, and I'll finish it tomorrow, but I'm going to still give you the worksheet tonight.